Hi there, my name is Nico, and in this video I'll be walking you through how to build your very own post-it drawing robot and control it with MarIOnette, a Blender plugin designed for controlling animatronics. We'll cover all the basics: where to find the software, installing the plugin, creating a rig in Blender, assembling the robot, and then linking the rig to the motors. All of the source code, model files, and Blender files can be found on the project's GitHub page. Let's get started. To install Blender, follow the instructions on their website. The current version is 3.5, and MarIOnette has been tested to run on Blender versions as early as 3.0. Once Blender is installed, navigate to the GitHub of the project, then the Blender scripts folder, and download the marionette.zip file. Also, download the .blend file for the drawing robot in the examples folder. If you're comfortable with rigging in Blender, download the post-rig file and skip the video chapter on rigging the model. Otherwise, download the pre-rig file and follow along. On macOS, open up Blender and go to Edit, Preferences, and then Add-ons. Click on Install in the top right and navigate to the zip file you downloaded. You should now see MarIOnette down below. To enable it, hit the check mark on the left. Now you can close the Preferences panel and in your viewport, hit the N key to bring up the side panel. You should see MarIOnette as one of the options. And on Windows, you're out of luck. Just kidding. Installing MarIOnette on Windows is a little bit trickier because of app permissions. Open up Blender by right-clicking and running as administrator. Now install Blender as you normally would using the .zip file like in the macOS instructions. Go to Edit, Preferences, Add-ons, click on Install in the top right, grab the .zip file, and enable the check mark. Again, check the side panel by pressing N and checking to make sure MarIOnette appears. Let's go ahead and get Arduino installed. Go to the Arduino website and navigate to their software page. Here I'm installing Arduino 2.0.4, but older versions of Arduino should also work. Once Arduino is installed, we need to install a couple of libraries, Excel Stepper and Adafruit NeoPixel. Do this by clicking on the Library Manager icon and searching for the libraries. I'm hoping to add support for Platform I/O in a future release, so periodically check for updates on the GitHub. You'll need to print out the robot parts with the files found on the GitHub. Here's a time-lapse with my print settings, which you may need to modify based on your specific printer and filament type. And while that's printing, let's rig up the model inside Blender. Open up a new Blender window, select everything inside by pressing A, and then press X and delete. We're going to import the OBJ file, which you can download from the GitHub by going into File, Import, OBJ, and then navigating to the exported file. Now, my CAD program, which is Fusion 360, exported this in millimeters, but Blender is expecting meters. So it comes in looking very, very large. So what I'm going to do is hit the N key or click on this little caret here to bring out our menu, go to Item, then I'm going to click drag to select X, Y, and Z of the scale and type in 0.001 just to scale it down to where it needs to be. From here, you can go to View and then Frame Selected or Numpad period just to frame everything inside. First, I'm going to select the object, then I'm going to do Command A or Control A, and then apply the scale. And now our scale is nice and evened out. So this OBJ imported as one object, but it has a couple different meshes. So if we click on it and press Tab to go into edit mode, as I hover over the meshes and if I press L, you see it's selecting different meshes. So we're going to go ahead and split that up into all the different objects. So I'm going to hit A to select everything, hit P, and then split it up by loose parts. And now you see in our outliner, we have lots of different objects. So what I'm going to do next is I'm just going to quickly go through and reorganize everything inside of my outliner, just so that it's easier to manage and work with. One thing I'm going to do is I'm going to join a couple of objects together to make it a little bit easier to parent everything. So for instance, my servo, I'm going to go ahead, select all the parts of my servo that are different by clicking on them. You can also do a box select here and then do a Command J operation to join everything. And then when you click it and you move it around by pressing G, you should be able to see that it's one solid object. Select one object first, then box select. So you have one object that's yellow and the other ones that are orange, and hit Command J to join. And again, I'm just going to move around to make sure everything is joined. I'm going to do the same thing with this upper arm. So I'm going to connect these together. And I'm also going to connect these together. And finally, I'm going to take the lower arm and connect these three segments together. Great, now that I have my objects nice and organized inside of my Blender file, I'm going to go ahead and create the armature. So to start off, I'm just going to hit Shift A and we're going to create an armature. Next, I'm going to go into my armature settings and I'm going to change a couple of settings just so it's a little bit easier to view. So I'm going to change the display mode to stick. I'm going to make sure that it shows up in front of our geometry, and I'm also going to enable axes so it's a little bit easier to debug. So what I'm going to do now is click on my armature and hit Tab to go to edit mode. I'm going to zoom out to this node here, and I'm just going to hit G and then bring this down on the Z axis. So you can hit G and then Z, GX, GY, vice versa to move along a specific axis. If you don't want to use shortcuts, you can also click on this little move tool. So when you select something, it gives you a widget and you can go and select it that way. So what I'm going to do is move this to roughly where the body is. This bone represents the root, so I'm going to rename this root. And this is just responsible for moving everything together as one. So if I need to move some of my objects inside of the scene, everything will be referenced to this. Next, we want to create some of the bones for the arms, but we want to make sure that they're centered and they're rotating around our little pivot points. So in order to do that, I'm going to hit Tab to escape from edit mode. I'm going to click on the upper arm and I'm going to hit Tab again to go inside of edit mode. So next, I'm going to hit on Z here so I can view this from above. And I'm going to zoom way in here to all these vertices, and I'm just going to select a ring of vertices here. So what I like to do is hit C for circle select and scroll until my little selection is large enough to select everything. Click with your left mouse button and then click with your right mouse button to exit circle select mode. So you see now that we have a ring of these vertices selected. Next, what we're going to do is we're going to hit Shift S and we're going to select cursor to selected. And what this does is snaps the 3D cursor where objects originate from when you create them, and it snaps it right to where we want it. So now that we have that, we can go back to our armature by hitting Tab, clicking on the armature, hitting Tab again, and now that we have this cursor, when I hit Shift A on my keyboard, it's going to create a bone. Again, this is very tall, so I'm just going to bring it down a little bit here. And now we need to repeat this process for this point of the bone right here so that it moves to this pivot point. So I'm going to hit Tab to escape edit mode. I'm going to select this link right here and I'm just going to hide it so we can see a little bit more clearly. Next, I'm going to select my upper arm again, hit Tab, and next I'm going to just zoom in, select a nice ring of vertices, hit Shift S, cursor to selected. You want to make sure when you're selecting this that you only have one ring of vertices selected. So you see here I had two selected, so it snapped the cursor to the average between the two. So I'm going to click just to deselect everything, hit C again, select, Shift S, cursor to selected. And now it's nice and centered. So hit Tab again, go to our armature, hit Tab. We have this little point selected here, so now we hit Shift S and go selection to cursor. And what that does is it snaps that little selection to where we created our 3D cursor. Now if we look at this from the side, we can see that the bone is tilting downwards a little bit, and we don't want that. We want it to tilt perfectly straight, because once you parent the object to the bone, it'll start rotating strangely. So what I want to do here is I want to look at the head and I want to look at the tail, and you see here that our Z values are different from each of these. So what I'm going to do is I'm just going to copy and paste from this one by hovering over this field and hitting Command or Control C, and next you go to this guy right here, this tail Z value, and do Command V. And now you see our bone is going into a straight line. One other thing that you want to check is you want to make sure that the roll angle is set to 0 degrees. This just makes sure that once you parent everything is rotating around the correct axes. So now that we have this bone created, we want to create one for the lower arm. So with this segment selected, I'm going to hit E to extrude, and then hit Y to extrude along the Y-axis just to get it close to where we need it to go. Next, we want to snap it to this ring of vertices here. So again, tab to escape edit mode, click on this ring, tab again, gonna go up here. And here we have a little bit of a more tricky selection. So what I'm going to do, instead of doing my normal circle select, is I'll select the edges, and I'll select one edge, and I will hold down Command as I kind of go across and click and select this ring of edges all the way around. There's lots of little different ways to do this inside of Blender. This is definitely just one of the many. So now that everything is selected, we're going to go ahead and hit Shift S again, cursor to selected, that snaps it to the middle, hit tab, click on our armature, hit tab again, click on this little point, Shift S, and selection to cursor. Again, if we view it from the side, we see that this whole thing is angled upwards. So we just want to make sure that our Z's are lined up. So I'm going to copy this value, paste it to this value, and now everything is in a nice straight line. And once again, our roll is set to 0 degrees. So now you see this whole thing is set up. And if we show our arm again, that is also enabled, which is great. Okay, so now what we can do next is symmetrize these bones, which means we just mirror them across the x-axis, so we don't have to go back and forth between the edit mode that we were doing before. So I'm going to select this bone. We need to rename them so Blender knows which side is on the left and which side is on the right. So I'm going to call this upper arm dot left. I'm going to call this lower arm dot right. And then I'm going to select both bones. And from here, you can press F3, or on Mac, I have to press Function F3 to bring up our search panel. And you want to search for Symmetrize and hit Enter. And that mirrors our bones across the x-axis. Finally, what I'm going to do is I'm going to take this bone here, go down to Relations, and make sure it's set to root. And you can see that now this bone is parented to this bone, so that when we move the root, it'll move everything else. I'm going to do the same thing to this upper arm as well. And now what we want to do is we want to go ahead and create our inverse kinematics. So clicking on one of these points, we're going to hit E and then Z to extrude another bone down. And now what we want to do is we want to split this bone away from the rest of the rig, because we want it to function separately. We want the rest of the armature to follow it when it moves around. So what I'm going to do is hit Y, and then that splits the bone, and you can see that it's split because its parent field is left blank here. So now we can press tab to exit our edit mode, and now we can go through the process of linking all of our geometry to the armature. There are some add-ons that do this for you automatically based on proximity. Because I don't have that many objects, I'm just going to go through one by one and show you how to do this. So one thing to speed this process up is if you go to Edit and you untick Lock Object Modes, this will speed up going between Pose mode, Object mode, Edit mode, all those different modes, so that we can link this up really quickly. So I'm going to go ahead and I'm going to start with this arm here. So I'm going to click the arm, then I'm going to Shift-click my armature, and I'm going to go up into pose mode. So now we have this pose mode selected. I'm going to click on the bone that we're interested in, make sure it's highlighted blue. Next, we're going to do Command P to parent. That opens up your parent menu, and we want to make sure this is set to bone. So now that you've set that, selecting this bone, and you can hit R to rotate, you see that as you rotate the bone, the object rotates as well. So we're going to go ahead and do that for all of the different parts of the armature. Click on this arm, shift click to select the armature. This bone is currently selected, so we want to click on this bone, and then once again, Control P. And then you're just going to repeat this process for the rest of the rig. So now that you have the whole thing rigged up, what you can do is click on your root bone and hit G to move it around, just to make sure that everything is linked to where it should be. You can select some of the bones and rotate them around. Let's see if everything looks okay. And it looks like I've parented this correctly. So up next, what I'm going to do is I'm going to limit the motion of some of these bones so that they don't rotate around the view orientation. So right now, if I go to rotate this bone, it's not really rotating how a servo would in real life. We only want it rotating around the Z-axis right here. So you need to enable a couple things for it to do that. One is for forward kinematics. So if I just click on this bone, I hit R and then Z, that's what we call forward kinematics, where you're going each arm individually. And then we also need to do it for inverse kinematics, which we'll set up in just a short second. So what I'm going to do is I'm going to select all of these bones by shift selecting everything. And inside this item menu here, you see that we're currently set to quaternion. We want to switch that over to Euler. So I'm going to hold down Option or Alt, click, and then hit XYZ Euler. And what the Option hotkey does is it makes sure that that selection gets applied to everything. So if I go through all my different bones now, you see that everything is at XYZ Euler. And because all of our axes are pointed up in the Z direction, what we want to do is we want to go ahead and lock everything except for Z. So again, I'm going to hold down Option, and I'm going to click this little lock icon next to the X and next to the Y. So now if I go through and I hit R to rotate, you notice that it's rotating only around the Z-axis and no other axis. So that's great. We have our forward kinematics sorted, but now we want to go ahead and we want to create some inverse kinematics, which makes things a little bit more interesting and a little bit easier to animate. So what I'm going to do is I'm going to click on one of these arms, and I'm going to go into here to our bone constraints, and what I'm going to do is I'm going to add an inverse kinematics constraint. So here you can specify the target. So in our case, we want to try to find this bone right here, which I'm going to just quickly rename to IK pen, because this robot is following a pen. So jumping back into our bone constraints, you have our armature. You want to click on IK pen as our target. Leave the pole target blank, and for chain length, we want to do 2 because we have a link length of 1, 2 right here. For rotation, you don't want to lock it on rotation. You want to keep it where it is. So same thing across this side. You want to go ahead and add an inverse kinematics constraint. Again, if you have lots of these objects, there are add-ons and there are ways in Blender in which you can copy and paste constraints. So there are definitely ways to do things a lot more quickly. So now that we've added inverse kinematics, you can see that the bones within inverse kinematics are highlighted yellow here. If we select our IK bone, hit G to move it around, you see that it's starting to move around, but we have the same problem where our axes are getting a little bit messed up. And this is simply because inverse kinematics is treated a little bit differently inside of Blender. So what you need to do is, again, select all of the bones that are rotating. You want to go into our Bone Properties tab here, drop down Inverse Kinematics. and you see a bunch of these little lock IK and X, Y, and Z. So again, we're interested in only the Z. So I'm going to hit Option, hold it down while I click on my X and when I click on my Y. And now what happens if we move this around? It looks like it's respecting everything. It's not moving up and down. Everything is looking good. One thing I'm actually going to do is I'm going to take this bone right here and I'm going to lock its Z height just to make it a little bit easier. It looks like it's actually on the Y axis, so I'm going to lock the Y. Yep, and now that IK can't move up and down, it can only move along the X, Y, and Z axes. So that's the IK hooked up. One thing that's really helpful in armatures inside of Blender is to have a switch between the inverse kinematics and the forward kinematics. So I'm going to quickly show you how to do that. First, I'm going to click on this and hit Option or Alt G just to reset its transformation. Also, one thing I'm going to do is I'm going to switch XYZ Euler and just lock its axes so that I can't rotate it. From here, we're going to hit Tab to go into Edit mode. And what we're going to do is hit Shift S and reset our cursor to our world origin. And then we're going to do Shift A to create a bone. And this is going to be called IK FK switch. So what I'm going to do is scale this down, and then I'm going to move it above my character's head here, just so that it's out of the way. So now inside of pose mode, I'm going to select my bone. I'm going to add a bone constraint and say limit location. So from here, I want to make sure that I'm limiting my Y location because it looks like we're traveling in the Y. I've also locked my other axes inside of the item properties tab. And I'm going to set my Y to, let's say, 0.1 and my space to local space. And then as we move, we see that we move up to 0.1 and then it stops. But you notice that here in this little panel, these values are going up, which is not good. We want this to limit itself to 0.1, because if it doesn't, then those values will get transferred to our rig. So we want to go ahead and reset this to 0. I'm going to click on this little effect transform button here. Now if I move it, it should stay locked at 0.1, even if I move my cursor above it. So now we're going to go ahead and link up the position of our IK-FK switch to the influence of the inverse kinematics constraint inside of each of these bones. So inside of here, you have a little slider called influence. If I go ahead and I take my IK and I move it to a position here to kind of showcase the effect, if I take that influence down to 0, you see that we switch all the way from our inverse kinematics to our forward kinematics. So what we want is we want the position of this bone, the switch, to affect the influence. And to do that, we create something called a driver. This is just a way inside of Blender to link certain properties and values together with each other. You're going to go ahead and select a transform channel, select Armature, and we're going to do IK-FK switch. We are looking at our Y location, and we're looking at local space. The other thing we want to do is we just want to multiply this value by 10 because we've limited our location from 0 to 0.1, and this influence field is expecting a value from 0 to 1. So we're going to go and do that, hit Update Dependencies, and now when we click on and drag our influence, we can see that it's actually affecting the switch. I'm going to do the same thing to this one. So I'm going to go in here, right click, copy driver, and then I'm going to click on my other arm and hit paste driver. And now if I move these around, you see that we have an effect. The next thing I'm going to do is I'm going to replace these default bone shapes with custom bone shapes and a little bit of text to make this a little bit more legible for animators. So what I'm going to do is create a new collection and call this bone shapes. I'm going to go ahead into my bone shapes, make sure I'm in object mode. I'm going to create a simple plane. And next I'm going to go in, add a bevel modifier, set 2 vertices, and give it a couple of segments. Let's say 8. Nice little square bone shape. We can do now is select our armature and jump into pose mode, select the bone that we're interested in, and in viewport display we can go and select an object. So now you see we have our stick, which was replaced by this plane. What I'm going to do is I'm going to select my scale and set this down to something like maybe 0.2, 0.3. Yeah, that looks good. So that looks good. What we're going to do next is click on our plane, hit Shift D to duplicate. I'm going to hide the original plane. Next I'm going to tab to edit. Go to face select mode, delete only the faces, so we have a nice outline going on here. And what I'm going to do now is rotate this along the x-axis, so hit R, X, 90. Go to my front view, and then again go to edit mode, and then I'm going to scale everything down and just position this until it's roughly where I want it. I'm also going to take the bevel modifier and tone it down a little bit. I'm going to scale on the X just so it matches our shape. Something like that. And then if I go to edit mode, I'm going to see where the top position is. Select this top and move it down like that. So now you have a nice little slider. So when you select, you can see going from 0 to 1. Finally, last thing I'm going to do is make sure that we have some text so that this is legible. So once again, go into my bone shapes collection, go to object mode, hit Shift A, and let's add some text. I'm going to hit tab and type IK, hit tab again, rotate on the X, 90 degrees. I'm going to go ahead and place this right here, just like that. And then I'm going to Shift D to duplicate, hit Z to move it down, tab, and then I'm going to type in FK. And I'm just going to go to my front view and make sure everything is there. So now what I'm going to do is I'm going to take my text and my outline, Shift select to make sure they're all selected, Shift select my armature, go to pose mode, click on my root bone, and we're going to Command P and parent everything so that once we move things around, it moves that collection around as well. Last thing I'm going to do is I'm going to make sure that this bone is parented as well. So I'm going to go ahead and go to Relations. I think I need to do this in edit mode. Yep, that's right. Click this inside of edit mode and parent it to the root. So now if I move things around, everything moves together except for our IK, which if you wanted, you could parent this to the root bone. I'm going to keep it where it is just for now. One other thing you might want to do before animating is disabling these relationship lines because it looks a little bit distracting. You can do all of that up here inside of your viewport overlays. So inside of viewport overlays, there's an option called relationship lines. There's also a way to disable axes. So if you find the XY axis distracting or the floor distracting, you can disable all of that. What I like to do is turn all of that off and then create my own little background. So I can create a little background collection here, jump into object mode, create a little plane, move that down so it just barely touches. And then from here, I can select one of my edges and extrude it upwards by hitting E and then Z. Next, what I can do is give it a little bevel modifier and give it a couple of segments. Let's say 20, and crank this value up. And then you can right click and shade smooth to make that shading nice and smooth. You can also take this and scale it along the X just to make it a little bit nicer. So now as you're looking at this, it's just a little bit cleaner, a little bit less distracting. Once you jump over to any of your shaded views, everything will be white. So what you can do is select your plane, assign it a material, make it maybe a little bit darker, and do the same thing to some of your objects as well. And that's it. Our file is now ready for animation, so you can go inside of MarIOnette and start adding your actuators in order to link that to your microcontroller. Looks like all of our parts are done. So here's a quick assembly guide. Some of the 3D printed parts need to be threaded, which you can do with the screws themselves, or with a tap, which is my preferred method. Here are all the parts with their respective tapped or drilled through holes. Once all the holes are drilled and tapped, you can begin the assembly. Start by installing the servo horns onto the servos as shown, and tighten the included screws on the side until snug. Install the large bearing into one of the lower arms. Now push the servo cables through the chassis, followed by the servos. Secure them using the M4 by 8mm screws. Next, attach the face with the M3 by 6mm screws. Press the bearings into the upper arms with a clamp or a pair of pliers. Be careful not to damage the bearing if you use a really aggressive method here. Attach the upper arms to the servo horns with the M3 by 8mm screws. Place the lower arm with the bearing below the non-bearing lower arm and attach them together. Now install the bearing clamp with the one M2 by 10mm screw. Place the pen holder on top of the assembly and push the M2 by 14mm screws through and detach. Now you can place the lower arm assembly onto the upper arm bearings and attach them together with the small bearing clamps and M2 by 14mm screws. You can use the M2 by 10mm screw to finish off the pencil clamp. You can now install the pencil and clamp down. I won't go over every part of the assembly process for the breadboard, so here's a picture of the setup. I am using an Arduino Nano and have the servo signals attached to pins D8 and D9. 4 AA batteries are linked up into a pack and they power the servos. The Arduino gets power from the USB cable. Back inside Blender, open up the actuator panel and create an actuator for the left servo. Specify the armature and bone, and then the axis of rotation. You can toggle visibility of the axes by pressing the button in the panel to make it easier to find the right one. Once you select the appropriate angle, press the lock axes button in order to make sure all the degrees of rotation except the one we are interested in are locked. Specify the pin and change the mapping as shown. We'll edit these values shortly. Repeat the same steps for the right servo, being sure to set the correct pin. Go to the sync panel, specify a folder, and hit generate. Now open up the Arduino file that was generated and upload it to your microcontroller. Let's adjust the mapping of the bones so they match the angles of our servos. In the serial setup panel, hit refresh list, and then select the serial port of your microcontroller. Tap on connect. You should see the servos move a little bit to some predetermined position. click on the IK-FK slider and move it until it's in the FK position. In the actuator panel, select the left motor. Making sure you are in pose mode, select the left upper arm bone and then view its properties on the right. Notice how all the axes except one are locked from pressing the Lock Axes button during the initial setup. Change the unlocked angle to 90 degrees. Adjust the second value in the actuator panel until the Blender window matches your physical setup. Now change the angle back to 0 degrees. Adjust the first value until you get a match. Repeat the same steps for the right servo, but adjust its values to -90 degrees since it is mirrored from the left servo. If your left and right servos are switched, double check to make sure the correct pins are set inside the actuator setup panel. Switch back to IK mode and move the IK bone around to see the robot move. Or have it follow a path by changing the follow path mode in the rigged Blender file. More updates and features are coming soon, and look out for a second tutorial that will go over different motor types and LEDs in the coming weeks. Alright, bye-bye now.